GPS check? A picture here. We think we got audio. Okay, what was a status of another engine fired in about 20 seconds or so?
That's the best test we've had so far.
All the shots we did today. Yeah, big plume of smoke. For the sightseeing what we're doing right now is they're getting out to the option. That's the next step. And that'll take probably about 20 minutes. That fill. Kind of basic background. There's a liquid oxygen. That's what they use to transfer the LOX into the rocket. Yeah, I see one of the LOX team members in a white hazmat suit. They're ready right now.
That seems like such a delicate job.
That's a little more complicated than the we did back in 07, which is standard. No problem with any fire hazard or oxidation hazard. So we did three full sets of cold flow tests where the pressurized liquid oxygen tank with liquid nitrogen and go through the entire fill, pressurization, and launch sequence right there, which is pretty cool. Some of the things they observed when filling with liquid nitrogen was they build up a big frost layer on the LOX tank, and actually all the plumbing and piping were just covered in ice, just like you saw on the NASA shots. The longest run they had was about 15.5 seconds. Everything worked just as they expected it, and when it was all done, there was a large snow cone stuck to the pavement where all the water and liquid nitrogen was in.
Were you guys talking about that? She's like, oh yeah, they're making snow cones, and I was like, they're supposed to be building a rocket, why are they building snow cones? Like, they were testing. It worked out.
Yeah.
They only had one leak last time, I heard, and then they fixed that already. Obviously, otherwise we would not be launching.
Yeah, they've had to check every connection, everything over and over again. Pressure check with gaseous nitrogen in the maintenance building before they take the rocket out to the launch pad. And that's to make sure there's no pressure and no leaks. On the kerosene side, that's definitely don't want any leaks. That's okay, we're getting some wind noise here. Kerosene leaks, fuel leaks are bad, but the liquid oxygen leaks are the worst. We don't have any leakage on the LOX side.
Just out of curiosity, can you explain what would happen if there was one?
Probably a large explosion.
Due to?
A leak of liquid oxygen or pure oxygen in the environment, any kind of ignition with that much oxygen in the immediate environment, anything will burn.
Alright.
So including all the fiberglass, the aluminum, everything that will actually combust.
Oh wow.
And what was that in the training that NASA gave them last weekend? Because we had folks from NASA JPL and NASA Stennis came out to OSML and did 2 days of training in the classroom with the SED team going over oxygen handling safety, combustible safety, material compatibility. So essentially they got like a graduate level course in 2 days.
Yeah.
But to today for the liquid oxygen handling, that's done by staff here at Friends of Amateur Rocketry, FAR. So the UCSD team is not actually doing the LOX fill. That's the FAR staff handles that. That was the agreement we all had. But everyone's been trained on the procedures of how to go through that. So after they get the liquid oxygen in, then they'll use gaseous nitrogen to pressurize the whole system up to around 600 to 700 pounds. I think it's different. Kerosene is a different pressure than the liquid oxygen, but it's in that range, upwards of 700 pounds per inch. And that's part of the reason why it was cleared out into the bunker areas.
Yep.
Now here at FAR, they've got several partially underground bunkers. There's one in the center of the field that you might be able to see in the background. It's to the right of the rocket as you're looking at it. It's only about 1 foot exposed above the ground, and there's a 6-inch heavy plexiglass window, like 3-inch thick plexiglass under that. Out here in the periphery of FAR, there's 2 different sets of kind of like dugouts or bunkers that are berms in the dirt with concrete block and concrete ceilings over them. So they don't have to worry about things falling back down. Sometimes parachutes don't work, rockets break up, and debris falls down.
So I think most of the rockets that have launched today have all deployed parachutes.
Yep.
Yeah. So everything's going well so far.
Yeah, the SEDS rocket, Vulcan 1, has a parachute system, a recovery system in it, and they put a lot of time and testing in that too. Several discharge tests that are small. They actually use a small black powder charge to eject the parachute out of the recovery tube. And we've actually tested those in the lab a few times. Yeah.
Probably gave our neighbors a bit of a scare.
Actually, in that industrial park, it's not as noisy as
Oh, good.
some of the
That's
stuff that's
good.
on there. So, now, late at night, that's a different story.
Yeah,
but,
that's true.
It's been interesting working in this environment. If you see us like filming with a laptop a lot, it's because the screen and the keyboard is completely covered with sand and dust.
Yeah.
And we can't even see what we're working on to get the live stream started. So we're working our way through that. So we get a lot of things. The secret phone talk here. So background noise.
Working.
But there are a couple of folks here that do have servers on their cell phone and they're watching the live YouTube stream while their cell phone's here where you get some feedback if the audio is working or if the stream's still going.
Yeah. We have a whole crew here helping us. I think we had probably like 4 or 5 people keep this out and just troubleshooting, trying to get it to work. And now there's signals too, having this still.
Yeah.
That was nice. And when we couldn't get the live stream up, one of the SEDS people actually offered to do a Google Hangout on his phone. Yeah, he just went and did it. So that was awesome.
Put it on YouTube so we'll be able to play it back and edit it down. The false starts we had. Down to a good viewing video.
Yep.
But yeah, let's keep together. Put together a live stream.
That's what I like about engineering, though. If you're trying things on the fly, you make things work however you can. That's the fun part. Not ideal, but it's fun.
It's fun when it works.
Yeah, definitely. Wind seems to be doing okay with that satellite, so we'll see.
Yeah, our satellite dish is held down with 4 large concrete blocks, and so it's pretty stable right now.
Yep. Not going anywhere. The landscape here is really cool, though. Especially at night, when the sun's setting and stuff. You can see the moon totally. It looks really cool.
Yeah, we got it this morning just before moonset.
Yep.
Yeah.
Yep.
And the sun was just coming up on one side and the moon was setting on the other side. It was pretty awesome.
Yeah.
Thank you.
Thank you. We have people.
Oh, Yeah, I just heard Jesse yell 10 more minutes or so. Jesse Lang, the team president, he's been leading the group through all of this whole year. Just incredible amount of work they've all put into this.
They've been working so hard this entire week. They want to make sure everything goes smoothly. They want to make sure their rocket goes up, parachute deploys. Yeah.
Something that you really can't reschedule this.
Nope.
There's no, yeah.
That's all you need.
Yeah, this would be their big claim to fame is the first launched liquid fuel rocket with a 3D printed engine. It's pretty awesome. It was their own unique design, and we were meeting with NASA several weeks back. NASA engineers, they would be approaching it from a more traditional way and just try to figure out how to take one of the traditional designs and 3D print it. Whereas the SED students had their own ideas for a novel design to make the combustion more efficient, and they came up with an idea that could also be traditional manufacturing made this rocket engine.
Wow.
Way to reduce the cost of space. By 3D printing, they can come up with a more efficient, more cost-effective engine that will reduce the cost of space flight.
A lot of these students get internships with places like SpaceX and NASA and JPL. Very, very, very smart ones.
It's going to be a JPL.
Wow. That's cool.
And I was talking with the CubeSat team. They're moving along with some competition for their custom designed CubeSat. Everything goes out, they'll actually be on a NASA CubeSat. Good for a college undergraduate project.
Yep.
So the SEDS is actually SEDS is students for the exploration and development of space. And this is really just one part of the team. The Vulcan 1 launched second set of teams, the CubeSat team, there's another propulsion team. It's CubeSat is like a standard unit. It's like 1 unit. It's like 10 centimeters is a standard unit in terms of satellite size. And so a 1U or 1 unit CubeSat, which is a 10 by 10 by 10 centimeter micro satellite.
Okay.
So it'll have solar panels on it, it'll have different sensors and communications equipment, but they're special functions. They tend to be, they might be generally short-lived as opposed to very long-term satellites. They'll have special functions. Communications function. The idea of the CubeSats is that they're standardized, they're almost going to be a commodity, so they get the cost of instead of each one very customized crafted satellite.
Gotcha. So it's a completely different project from the Vulcan one.
Oh yeah. It does have propulsion in it to get it, into orbit around the moon. And they actually showed me that those were 3D printed also. Special engines that are about as big as a quarter in diameter. Little tiny engines, and the orifice pattern was just like little tiny dots to get the flow mixture right into the engine.
Wow.
But there again, that's another design that can only be 3D printed out of metal. I think both engines. I know the one on the Vulcan 1 is printed out of Inconel, which is a nickel alloy. It's a very tough, heat-resistant alloy. So the 3D printing we hear about all the time, it's on all the news, everyone's talking about it, is plastic. But there are techniques, methods out there in industry to print parts out of metal, different kinds of metal. It works a similar way, but essentially you take a set of powdered metal, powdered and they use a high powered laser to fuse it near the time. So instead of
pretty much walk out there and just go get it.
Yeah, the facility we're on, Friends of Amateur Rocketry, is a 10-acre private land. That's, as far as a nonprofit organization, they support rocket launches for different organizations, Girl Scouts, Boy Scouts, schools, all levels, and even some private companies that are getting into space exploration, space launches. So this is private property where we're surrounded by Bureau of Land Management property. So it's mostly just scrub brush and tumbleweeds and lots of sand, filled with rattlesnakes, scorpions, stuff like that.
Yep. This is a chaparral for Ariel. How many cars do you think we have here? There are a lot of cars here.
Probably, just guessing, 40 or 50 cars here. So it's quite, in the last few hours, people start showing up.
Yep.
Some are here just to watch. There's a series of smaller rocket launches earlier, all solid fuel, and a few static test amplifiers. The last big one are the largest ones.
Yeah.
But even just some small rockets, just STs, it's down to that scale. The Vulcan one will definitely be the largest thing that'll shoot all day.
Oh yeah.
Oh, you see liquid oxygen venting off the top end, way up the rocket. You may not be able to see it on this camera, but there's a plume of exhaust, which is liquid oxygen venting out the top end. So they leave the top vent open during the fill procedure until they get the right amount, like 2 or 3 gallons in there. And they actually do it until they see liquid oxygen coming out in liquid form on the top vent.
Wow.
That's how they know it. Okay, let's fill.
Yep.
Right now it's just gaseous, very cold gaseous oxygen coming off that has that condensation plume out the side of the vent. When they see actual liquid oxygen, it kind of sputters out droplets. So when they see that, it kind of stop filling and close the vent. And at that point, pressure will start to build up.
Okay.
It will be covered in frost. Then they'll pressurize the main system with nitrogen. So all the tanks lift up to the 600 or 700 pounds per square inch, and they'll be ready to start the launch sequence.
So how long did this take to build?
Pretty much a whole year.
Wow.
They've been working at OSML since January. They were working with some UCSD.
Right. And when they came to OSML, they had the engine, but that was it?
The engine and I don't think all the tanks were done yet.
Okay.
And some of the electronics were done. Some of the control systems were done. The main control valve that mixes the liquid oxygen and the kerosene together was complete. The airplane was done. The system was not done yet. So it all pretty much came together this last 5 months.
That's pretty good, actually.
Every day, all this 30 and Sunday too. A lot of 3D printed parts. Some laser cut pieces, custom made. And also in the avionics or electronics section, there's a module above the tanks of the parachute system that has, they actually have 4 GoPros sitting 90 degrees apart, and they hack GoPros so they're actually wired into the control system of the avionics. So it will be streaming video, but they'll be recording HD video, 360 panoramic view up and down. So we're open for a good recovery so we get the data.
Yeah.
And a lot of other avionics that are recording all kinds of other data. There's a GPS on board, as you mentioned, for location, but that'll also give velocity, acceleration.
There you go.
altitude. So that's all important. Speaking of altitude, this will be somewhere between 8,000 and 10,000 feet.
Compared to what we've seen earlier today, what does that look like?
Could hit higher.
Okay,
Could hit higher.
got it. Because the ones that we've seen so far, they go so high you can't actually see them anymore until the parachute deploys, and you see a little poof of red, and that's it. But with this, we probably won't be able to see it for quite a while.
It'll take a while to see. But this scale, this size of rocket, it'll be more visible, so
Yeah.
we'll probably track it visually. But they weren't really, that's actually a relatively low altitude rocket. But this is for an altitude record. I feel like this rocket is to test the engine.
Okay,
Is the main point.
cool.
So if they can get it to 8,000 to 10,000 feet and a successful launch, that's a mission success.
Gotcha. So the white rail that the rocket is on right now, is that structural support, or will that actually help them get in the air?
Both. It's keeping it upright right now, and there are two launch lugs that are on the rocket, bolted onto the rocket frame. There's like a C channel on the rail that these lugs slide into, so that'll keep it, when it's sitting for loading right now, it keeps it vertical and secured, but it also guide it for the first 30 feet or so.
Okay, cool.
So get off to a straight start.
Right, good.
After that, it's just
Wait,
thrust.
all the
It's
way
just
to-
thrust. And if I remember right, the unloaded rocket weighs in around 120 pounds.
Wow.
And
Wow.
throw in, I'm not sure what, maybe another 100, 200 pounds of fuel and oxygen.
Oh, there you go.
But I think their estimated thrust was about 750 pounds.
Oh,
So the thrust to weight ratio was pretty good.
good, good.
So it should give us a pretty good acceleration.
Right. Hoping to see a big plume cloud around the bottom, like a full-on NASA-looking thing.
Yeah.
Smaller scale, but I'm hoping it'll look similar.
Yeah, liquid fueled rockets, you don't see much of that in nuclear reactors. Solid fuel, there's plenty of great providers. The ST's model rockets, school and such, to kind of hobbyist, semi-pro type rocketeers that are doing some larger stuff. We went to an event a couple years ago in Apple Valley. It was a dry lake bed called LDRS, Loud and Dangerous Rocket Ships. And that was everything from the small scale, tabletop size kit model rockets to some larger stuff, inside and peas, about 5 inches in diameter.
Wow.
And altitude records. We got FAA clearance to go up to 80,000 feet. Took a long time to come down.
Yeah. Yep. Can you explain the difference between solid fuel and liquid fuel?
Sure. Solid fuel is essentially a powder that's packed into the tube, and inside the actual engine is explosible engine. The nozzle is usually circular and makes the tube fuel, solid fuel. It just, usually through the nozzle. The smaller ones, the powder fuel burns from the top of the tank. So the hot gas does another feature that the top part will be like a small explosive charge, and that's what kicks out the parachute at the top.
Oh.
Actually, it's like a cork that pops out the top.
Okay.
So it'll burn for thrust for 30 seconds, and they get a different kind of fuel material at the top and forces hot gases up to the tube. Is pretty much always liquid oxygen and kerosene, something like that. That's usually a mixture of the two. And use the liquid oxygen because you get a lot more density.
Oh, yeah.
Just
I see.
use gaseous oxygen, you just wouldn't have enough
Yeah.
to sustain that longer burn. Gemini, Mercury all the way through Gemini, Apollo space shuttle, and some of our satellite launches as well. Solid fuel is usually good for lighter loads, but it might be less expensive. Solid fuel.
That's true. That's true. So how does the liquid fuel work?
Well, actually, the kerosene is and there's a manifold that they designed that brings all the plumbing and piping together. There's piping that runs inside of connected to, and there's a special piping actuator that opens up the fuel and the oxygen at the same time and forces it down into the engine. The top part of the engine, the elevated part they did, was it's like a carburetor where it mixes the oxygen and the fuel together in kind of a spiral motion, so they get a lot more mixing and flow before it gets down into the combustion chamber. And that's the and it's cone shaped, so they call it convergent divergent nozzle, because that special shape you actually get supersonic flow coming in the back end. So you can go from subsonic flow to supersonic flow. That thrust.
How they doing?
Oh, they're still filling. The oxygen is up.
Yeah.
That means that the vent is closed. Someone reaching up. I think they have closed again.
Is this a lake bed behind us?
Yeah, there's a satellite bed behind us. There's a business from the camera angle to the left of the rocket. It looks kind of like a layer of white with salt.
Wow. Do they know where this rocket is going to land, or are they just shooting it straight up?
It's going to be straight up, and it's really going to be dependent on the wind.
Yes.
Low altitude parachute deployment, so they don't have a lot of range travel.
Sand everywhere. I feel like our computer is progressively getting more sandy. We've wiped this screen off so many times, but it just all of a sudden gets sandy again.
Yeah, that's what you get when you broadcast from a sandstorm.
Yep, that's fine. We do what we can.
Yeah. Pretty good for improv.
Mm-hmm. Looks like people are just waiting.
Yeah, people are getting kind of ready for the show here.
Again, the hazmat suit is climbing up the side of the rocket.
I'm doing a second check of the vent valve.
And what group are they with again?
They're with Prince of Amateur Rocket.
Okay,
They're the
okay.
staff here.
5 minutes.
5 minutes, I heard. Okay.
Cool.
Yeah, it's a little hard. We don't have any direct communications with the crew on the launch pad, so we're just kind of getting it secondhand of what the status is.
See it launch. Looks like someone's got a camera set up over there too. It's up against
Yes. Either way.
Yep.
Chris has, and we can get a few minutes with him. Ellen, you want to talk out with him? Because we're trying to broadcast in a sandstorm.
Yeah, it's definitely windy out here, that's for sure.
What's the latest on field procedure?
Well, we encountered a few difficulties, but with that being said, it looks like we're just about getting ready to launch. Lost. We are just about getting ready to disconnect our lines from the liquid oxygen. Kerosene is all full, so now the next thing we need to do is close off our vent valves, so we are no longer venting out any of our liquid oxygen. And then we have to pressurize, and then we're good to go. So I'm expecting launch within the next 10 minutes or so. It's really exciting. This is a year's worth of work just about to come to an end, and I'm excited. Really excited.
Oh, same here. I don't think it's coming to an end. I think this should be a fresh start for you guys.
Of course. The end of a chapter is the beginning of a new chapter.
And a long book, I think.
That's right. So, to all the viewers, this is definitely an exciting time. We've been spending countless hours working on this rocket, especially in this last couple of weekends, and it's all come together. Well, I wish you guys could be here to see it in person. It sure is big sitting out there on the launch ramp. So, yeah,
it's going to be quite the culmination of a lot of hard work, and we appreciate all the work that the team has put into this. It's just been amazing to watch you guys work. It's all come together. So many different disciplines have to come together. It's not just aerospace, but there's like
finance people have come together to make sure that this happens, and it's exciting to see so many different people come together to make one project happen.
For you, it's a great experience, and this is how it really happens. That's how things work.
Can we explain to any of the viewers why perhaps 3D printing might be an exciting technology for the future of space travel?
Yeah, we touched on that about over the cosmos. You want to expand on that?
Well, I'd like to just mention that what's really exciting about what we're doing here next, if we're successful, we'll be the first students in the world to design NASA. What's really exciting about that is that 3D rocket engine is the most expensive part of a rocket generally, and so 3D printing, we have the opportunity for even as students to develop our own rocket engines and fly them. And so what that might mean for the industry is that now you get to drive down the cost of going to space. When you drive down the cost of going to space, it means you can send things up for cheaper. So you can send satellites up that provide internet to third world countries. You can go and perhaps mine asteroids. You can design colonize it one day. So it's like one step closer to that sort of reality that we kind of all dreamed about since we were little kids.
Oh, absolutely. I think it's fantastic for the technology to bring it down so far that it's accessible to graduate students who are now actually getting into spaceflight. That's absolutely incredible. I should think back in history. I know a college student that was recruited for his expertise in rocketry. He was part of a rocket club in Berlin. His name was Werner von Braun. This is how he started. Working in a club back when the rocketry was just getting started.
Yeah, and I look around and I like to believe that a few of the people here in SEDS are perhaps some Dr. Werner von Braun's. Fingers crossed. I think there's some very talented engineers here who've put in just a ton of work into this thing. So.
Oh, absolutely. I think you got some candidates having worked together very closely for that 5 months. Yeah, you definitely have some von Braun candidates in your fantastic team. So, looks like they're climbing down the gantry now.
Yeah. Well, Dan, I hate to say, but this might be my cue. I gotta head out to the bunker. To all the listeners, I'm excited that you guys are here to watch this with us, and thank you for having me. Dan, appreciate it.
Thanks a lot. And we'll just get the camera running here with mics on and enjoy the show. We'll be close back in the bunker.
it went successful launch though. So they'll gather a lot of data from that. And we got some other rockets that are heading out to the pad now too.
So that was interesting.
Yeah, that was a fast flight,
Very quick.
but a successful launch. That was the main objective. Team members here. Bunker, there was a lot of tension, a lot of nervousness, a lot of I think what's going to happen.
Honestly, beautiful launch. It looked picture
I said, a few seconds I could see it. It was a nice, like, hot blue flame.
Yes.
You know, the not yellow orange, it was like hot blue. Real hot burn. The avionics report were recording all the data. All the GoPros had SD cards to record all the video. Yeah, some forensics and analysis to figure out what went wrong with the recovery system.
Yeah.
And as we were saying earlier, I mean, they put a lot of testing time into that. It's
Yes.
good design.
Yes.
Very methodical in the testing. So we'll have to figure out what went wrong with that.
Yeah. Although they don't look too well. That was a good one.
We got a couple of drones flying over here. Video. On the field angles, I know they got some very close up footage. They've actually been doing a lot of detailed analysis. A lot about combustion efficiency of the engine, which is what this was all about. It's definitely a mission success. Stop and think about it, you know, for a group of undergraduate students, pretty much on their own, really.
Yep.
Self-funded.
Yes.
They did crowdfunding. They had some grants from NASA, but they did their own Kickstarter campaign, raised $24,000 to print their own engine.
Yep.
That's a pretty awesome accomplishment. Share their experience.
Yeah.
That's all.
Yeah. Speech right now.
Oh yeah. Oh yeah. Gotta have the congratulatory speech. This is their time.
The whole rocket will fit in the trailer.
Yeah, that'll be the next step is packing up, get everything back in, loaded up this afternoon and tonight. They'll probably do some analysis. They'll probably do a little bit of forensic analysis of the assembly area
Right.
in Hangar Bay this afternoon. To figure out what